Not many books actually change a person's life, but this book changed mine. Gaia, A New Look at Life on Earth, was published in 1979. Its author, James Lovelock, rattled the scientific world and electrified the rest of us by arguing that the Earth behaves like a single living organism that creates and maintains a viable environment for life. The Gaia hypothesis offered a coherent vision of the whole living world that echoed all our wisdom traditions and renewed the human sense of wonder. Lovelock's bold insights became the foundations of Earth system science, the study of systems like the circulation of the oceans, the maintenance of the atmosphere, and the relationships among the Earth's biological and geological processes. He has been called the most important figure in the life sciences and the climate sciences for the past half-century, and his stature has been compared to Darwin's. Now 90, Jim Lovelock is still pushing out the boundaries of knowledge. He published his most recent book, The Vanishing Face of Gaia, in 2009. I called on him at his winter home in St. Louis, Missouri, in January 2010. I wanted to start with a quotation from James Lovelock that I thought was absolutely wonderful, and it comes from an ideas show that David Cayley did long, long ago.
Oh, I remember well, yes.
Yeah, and I listened to that with great pleasure, and it was a real eye-opener for me. But you
was that the one in Toronto?
Yes,
yeah,
yes.
Yeah.
And you said at one point that the germ of the Gaia theory was your realization that the Earth had, quote, an atmosphere that was wildly anomalous, a strange, wonderful, and beautiful anomaly that sort of shouted a song of life right across the solar system, right into the galaxy. And I thought that was such a marvelous sort of image.
Good.
Yeah.
Thank you.
I wanted to take you right back to that beginning of when you
Yes.
began to suspect that the Earth as a whole could be seen as an organism. And tell me how that came about, and I'm thinking particularly about things like the atmospheric issue.
Well, it came about, and the story has been told quite a few times, when I was working at the Jet Propulsion Laboratory in Pasadena in California for NASA, and that was in NASA's youth. I first went there only 3 years after it was founded, and they were then, and I'm talking about 1965, just as now, obsessed with finding life on Mars. They still haven't found it, but it hasn't stopped them looking. And I'd put forward a paper in Nature that's suggesting that they were going about it the wrong way, sending biological expeditions there to look for microbes and things, because how the heck did they know there were microbes anyway? The only way to look for life on Mars was to check if the planet had a lower entropy than the other planets, following Schrodinger's, a great physicist's idea. And they naturally asked, well, how on earth would you measure entropy? And after a lot of thought, it occurred to me all you have to do is measure the chemical composition of the atmosphere. If it's way out of equilibrium chemically, then it's got a low entropy. And if there's life on the planet, it'll be bound to use the atmosphere for raw materials and a place to dump waste, just as we do. And this changes the atmosphere chemically way, way away from the atmosphere of a dead planet like Mars or Venus. That tells you whether there's life there. And one afternoon at Jet Propulsion Labs, I was in a room with Carl Sagan, a colleague of mine, Diane Hitchcock, and in marched an astronomer, Lou Kaplan. He said, look at this. And he brought great sheets of data. He said, here's the complete analyses of the chemical compositions of Mars and Venus. It's just come in from the Pic de Midi Observatory in France, where they have fitted a Fourier transform spectrometer, which had only just been invented at that time, actually by a friend of mine, Peter Felgert, and they coupled it to their telescope and were able to completely analyse the compositions of those atmospheres. And we said, well, what is it? They said, well, they're both almost entirely carbon dioxide with just traces of the other gases present. And I knew instantly that they were both chemical equilibrium atmospheres, just what you'd expect. And then I suddenly thought, but the Earth is so weird. When you look back at it, there you've got oxygen in abundance mixed with hydrocarbons like methane. If it were different in composition, it would be explosive. And we know that the methane and oxygen are burning continuously as a cold flame in the stratosphere, ignited by the high energy UV from the sun. So something must be producing the pair of them, and in substantial quantities. And it was easy to work out what the quantities were, because even then we knew the half-life of methane was somewhere in the region of 12 years. So it meant we're talking about nearly 1 million tons of methane, and about twice that much oxygen must be being produced continuously. And there were just no geological processes conceivable, or chemical processes like come to that could make them in the atmosphere as it was. And there's only one thing could make them, and that was life. And then it dawned on me almost and this all happened within seconds or so, but if you've got an atmosphere like that that's highly reactive, it would be unstable. So how on earth does it keep a constant composition? And we knew that it had to keep a constant composition over quite a few years then. Now we know it goes back millions of years, it's more or less constant. So that produced the idea of a regulator. And then Carl Sagan interjected and said, I think you're talking a lot of nonsense, Jim. I can't see the planet regulating itself. He said, the only thing that justifies your view is we astronomers have worried for years about the cool sun problem. When the Earth was first formed, the sun was about 30% cooler than it is now. So how on earth, if it's the right temperature now, was it not frozen solid right at the beginning? Or if it was frozen solid at the beginning, why aren't we now boiling? And because it's a huge change, 30%. So something must be working to regulate it. And then it instantly came to me, well, if the biota can regulate the gases, they can regulate the temperature, as we well know. You've only to change CO2 6%, and everybody's making a hell of a fuss. And it's the biota that make the CO2. So obviously there was the means of regulation was there straight away. And that was, in a sense, the Gaia hypothesis formulated then. And I didn't write it up until a paper in a journal nobody reads. It was the Proceedings of the American Astronautical Society. But it's there all right in 1968. And more or less said that. And of course it was wrong. I didn't know it then, and this was the thing that Richard Dawkins many years later and Ford Doolittle from Halifax both homed in on. There's just no way for living organisms to regulate anything beyond their phenotypes. So how could they be regulating the planet? Ford Doolittle was quite rude. He drew up pictures like, oh, do you suppose all the organisms gather at a big conference every year and decide on what next year's climate's going to be? That sort of criticism.
This is not dispassionate scientific discussion at all.
That's right, and Dawkins was even ruder, was saying that how on earth could a living planet naturally select? Is it a rival to the other planets and this kind of thing? And anyway, this forced me to rethink, and I thought very hard. And it took me about a year, and it suddenly dawned on me, it wasn't the life that was regulating the planet, it was the whole damn system of life and the environment, tightly coupled as a single entity. And well, of course, this didn't cut any ice with the critics. So what I did was to go and make a simple model, mathematical model. I should say, I paid for my living in those days by acting as a scientific advisor to a number of firms and government labs. And one of the firms, I was a consultant, I suppose you call it, although I wasn't really a consultant, because consultants spend their whole lives doing that. I was just using consultancy as a source of income. And Hewlett-Packard were wonderful, of course. I mean, were quite early in on the computer development, so I was more than familiar with how to program, and I used their first desktop computers for it, and could easily make the model I wanted. And that really did clinch it.
That would be the Daisyworld model?
Daisyworld model, yes. Yeah. It showed how a planet with two competing species of dark and light-coloured daisies could regulate its surface temperature with extraordinary accuracy and home in automatically on the most favourable temperature for daisy growth. That means it was about as solid as it could be. And it was a model that you could kick. I mean, you could make a big disturbance. What happens if, as a plague kills off 70% of the daisies? Does it still regulate? Yes, it does. Mm-hmm. Mm-hmm. It only makes a little kink in the regulation graph and things like that.
You faced almost a dogmatic insistence that organisms did not affect geology, and
that's right.
Which, on the face of it, seems. I was thinking. Actually, I was reading that passage on a plane the other day, and I looked out the window at the farms and the roads and so forth, and I thought, an organism doesn't affect its environment. Who could possibly have believed that? You know, but that was a big obstacle, wasn't it?
I think the obstacle arose for political reasons more than anything else. I call it's academic politics. The notion that biology is taught separately from geology is so entrenched, and it's existed for such a long time, about over 100 years, that they forgot entirely that back in Hutton's time, all science was, in the Enlightenment, was a single thing. You wouldn't dream of separating them. And it was only the political convenience of ambitious young men who got fed up with waiting for the old professor of biology to die that started their own little bailiwicks that gradually built up the separate professions of geology and biology and taught them as if they were unlinked. And to get out of that paradigm is not an easy thing for the biologist to do.
Well, and it's very successful, isn't it? Because that also is, in a sense, almost the beginning of reductionism, and it certainly is closely coupled with reductionism.
Well, it is, because you keep on breaking it down to smaller and smaller pieces, from which, when you understand them one day, you will be able to rebuild the whole. But you postpone that enormous effort indefinitely, not realizing you've gone way beyond the point where you can ever rebuild it.
Yeah. And you've been very critical of reductionism, and well, of course, your whole bent here has been to look at the whole picture and to assemble the information and the knowledge you needed from the different reductionist sciences as it was required.
Well, this has been helped enormously by my professions, if you can call them that, as a consultant. I was mainly employed by organizations as an instrument designer, by NASA to help them design instruments to analyze the surface of Mars and the atmosphere of Mars, by all sorts of other bodies like Hewlett-Packard to help them make instruments that they could sell, like gas chromatographs and so on. And the moment you get into instrument engineering, you get into systems and to feedback and to looking at the whole, never the parts, and realizing, if you've got any nous at all, that once you get into a feedback loop, you cannot argue from cause and effect by Descartesian type of reasoning. There's no point in it. It's as impenetrable is a closed-loop system as well. I mean, the nearest example I can think of is quantum entanglement. Scientists spend ages of time, wasted it not long ago, trying to make sense of the fact that tiny particles like electrons behaved as much as waves as they did as particles. And their minds couldn't cope with the idea that they were both. That it was just part of the system. And it's the same with any closed-loop system in its way. And I've a story I remember very well. Our best physicist in the 19th century probably was James Clerk Maxwell, another famous Scot, of course. And he went to a conversazione at the Royal Society about 1850, I think it was, or somewhere around about then, and saw Watt's steam engine governor at work. And he was fascinated by this thing because it self-regulated the speed of the engine very well, or rather regulated it. And Clerk Maxwell was at a meeting of the Royal Society, I think of the Council, 3 days later, and he said, "Gentlemen, excuse me if I seem somewhat sleepy, but I've spent 3 sleepless nights trying to analyse Mr. Watt's steam engine governor. I know that it works, I've no doubt about that, it's a good invention, but its mathematical analysis completely defies me." Now there's the man who came up with the electromagnetic theory, which made so much difference to our understanding of physics. But that baffled him. He published papers about 3 or 4 years later claiming that he'd solved the problem, but he hadn't really. You cannot solve problems of multiple differential equations. You can't, non-linear ones, without a computer. And of course they didn't have them in those days. So what he did was to introduce what they call linear transformations. That was turning all the differential equations into ordinary algebraic equations. This is a fudge. It worked, but it's a fudge. It doesn't work under all conditions, as the proper solution of the differential equations was. And that's how I was able to make Daisyworld, you see. With a computer, you can solve that mess of equations numerically, and there's no problems.
You continue to be a bit of a critic of science too, though, don't you? And particularly at the moment, a critic of climate science and the way that it's proceeding. And tell me what your criticisms of you basically argue that the situation may be much worse than the traditional sort of mainstream climate scientists say it is.
That's right. Well, you see, if you look at the history of the Earth, you find that it seems to be, as far as climate goes, to have 2 main stable states. One is about 5 or 6 degrees hotter than now, and the other at 5 or 6 degrees colder than now. And once in those states, it can stay there for long periods of time fairly stably. The interglacial that we are now in can only be called metastable, because history suggests that it only is tenanted for very brief periods of time. Our tenancy has been peculiar in that it's lasted longer than usual, but there no doubt will be explanations of that in time. But in general, it's a very brief one. So we are poised between slipping back into a glaciation and moving to a hot state. And either the Earth can run on stably in. And what we're doing, messing around with the atmosphere, has, strangely enough, the chance of doing either of those things. If we go on adding greenhouse gases and nothing else, we will almost certainly precipitate a flip to the hot state, because once we've added a certain amount and the Earth has warmed up a bit, the whole system starts emitting carbon dioxide at a considerable rate. The melting of the permafrost in Canada and Siberia it will soon be releasing methane and carbon dioxide in huge amounts. And that's the sort of process that will cause the jump up to the hot state. Mm-hmm. It's only one of 5. There's 5 total positive feedback systems like that. And several of them involve the ocean. So it's a complex process, but a whole system process, and you can see where it will go. But equally, if the burning of coal, for example, and of biomass in Asia goes on the way it's going, it may be they'll produce so much aerosol dust and smoke in the atmosphere that it'll reflect enough sunlight to counteract the CO2 increase and cool the planet. In which case, it'll flip, since we're in only a metastable state, it'll flip down to a cold state. And now the next glaciation, which is where it would have been going anyway, but for us.
It's and built into that description of the situation is the assumption that it will come as a flip. It won't be like the IPCC basically projects a slow rise in temperature. But your argument would be that that's not likely to be the way it actually unfolds.
Not so. It depends on the time scale you're looking at. If you go back to the warm-up from the last glaciation, that was 14,000 years ago it started, and there's general agreement it was triggered by the so-called Milankovitch orbital wobble of the Earth. The inclination of the Earth and its distance from the Sun vary with time, and this changes the irradiance of the northern hemisphere of the Earth, because the northern hemisphere that is the main driver here. And we know that the Milankovitch gave a kind of push about 14,000 years ago, and nothing much happened at first, and then there was a small rise in temperature, and then there was a great big one. It went up about 4 degrees Celsius, but only went up for quite a brief period in Earth history times, probably several hundred years, and then sunk down to even colder than it had been before, despite the heat coming in even more. And it wasn't until, I think 1,000 or so years later that it suddenly rose in temperature at a colossal rate, 3 degrees in 20 years. And that has now been attributed fairly accurately from collecting about a ton of ice from the correct depth at Greenland, corresponding to the period when this happened, which would be, I think, 12 or 13,000 years ago, and demonstrating that the gases that came into the atmosphere at that time were biogenic methane and carbon dioxide, and the most likely source was the permafrost melting.
Oh, okay, biogenic and, all right.
The C14,
yeah,
there was enough C14 to give it a date to when it had happened. And so they were to pin it down really tight.
Yeah. No, when you say biogenic, I was expecting you to say something like emissions from volcanic eruptions or something like that that belched a lot of...
Oh no, the really big emissions are biogenic always.
Oh, are they indeed?
Yes, the volcanoes don't do much. Trivial, almost trivial amount compared with the bio... Well, you think of it, you see, every year the life on Earth is pumping down 550,000 million tons of CO2 to form trees, plants, algae, all the rest of it. And every year, and the same amount of carbon dioxide is going back into the atmosphere as the consumers of those plants and algae and things oxidize it and put it back. Now that's a huge turnover. The amount we're putting in, 30 gigatons, is only about 6% of the whole of that thing. But it's enough to upset the balance.
So 6% is what we're putting in through industrial sources and so on?
Well, and agricultural. Okay. We tend to concentrate on industrial only, forgetting that agricultural is just as important. And it's all tied up with politics. There's this ridiculous guilt trip. We feel we treated the third world badly all along. Well, maybe we have, but this is history and past. I don't think you can blame young people around today for the exploitation of unfortunate native peoples in Africa. It just happened in part of their past. But the people in Africa are also adding to the global heat quite considerably by their own biomass burning, by their exceedingly inefficient methods of farming, mainly keeping cattle on unsuitable ground that would probably be a lot healthier if they didn't keep cattle there, and by having a social system that judges a man's worth by the number of head of cattle he owns, things like that. So the guilt trip is just stupid. We behave as we do because we evolved that way, and it's silly. I mean, it would be as silly as blaming the photosynthesizers 3 billion years ago for putting oxygen in the atmosphere, a desperately poisonous gas, carcinogenic too, that wiped out whole ranges of species, and the EPA would have disapproved entirely on it.
The photosynthesizers government.
That's right. I mean, when you get politics mixed up with a subject like global heating, it becomes ridiculous, to say the least.
Well, I've just gotten confused about a number here, because it seems to me that you said that 23% of greenhouse gases came directly from the breathing and other emissions of human beings and the animals associated with them, and now I thought you were saying just now 6%.
26% of the 6%.
Oh, all right, okay. Yeah,
Yes.
okay, that's the piece that I had missed.
Yes.
Because of course, when you start to think about 23% of
that would be huge. That would be disastrous. No, we're not that bad yet.
But I'm not enough of a scientist to pick that up. But
well, it's my fault. I probably haven't made it clear enough.
I don't know. But in any case, let's go back to that question of agriculture, because you. If I were translating this into the Christian terms in which we both grew up,
That's right.
I almost get the sense that you think of our careless use of fire, our remote ancestors' careless use of fire, as being like original sin. And if there's a second...
No, like the production of oxygen. Just as damaging, just as dangerous, but with just as huge a potential.
Okay, so, all right. Yes, so you're right, the use of fire afterwards.
And in fact, had it not been for the production of oxygen, we wouldn't have had any fires.
No, of course. But the second big area that you're very strong about is the use of land for agriculture.
Yes.
And that seems to me to get us into a kind of a conundrum. If you have this huge population, can you really not do agriculture on that scale?
Well, if in a science fictional world, which we do not live in, you could synthesize food using nuclear energy or large-scale solar energy, anything like that, from raw chemicals, and get us out of the loop and let the world go back to Gaia. I mean, that would be a nice option that would sustain a large population living in tight cities. But just let the land go back to natural ecosystems. The great danger of farming is that, particularly bad farming, which most of the world is that it destroys and takes away the natural vegetation, which is much better evolved to handle the problem of regulating the planet. Farmers' fields are not the right thing for regulating planetary atmospheres and climates.
And agribusiness fields even less so.
That's right. Yes, indeed. I mean, you're closer to the natural. This is one of the reasons, emotionally, why I was so attracted to the English countryside I grew up in. It was a kind of very low-scale farming that humans were much more a part of the landscape and playing their role in it. And the notion of things like hedgerows separating fields gave linear habitats for all sorts of small animals and birds and so on and so forth. How infinitely better than a barbed wire fence. And it was that kind of thing, and it looked beautiful, as well as being seemly in an ecological sense, because it's going so rapidly, it's almost gone, as far as I'm concerned. It still looks to a casual visitor fairly nice, but it's nothing. That doesn't even vaguely compare with the England I knew when as a boy, that I went around on a bicycle.
Even in Devon and Cornwall?
Oh yes, especially in Devon and Cornwall. Cornwall is a dreadful mess. It's a bit like California. They're all dropping down there, and all the fruit and the nuts.
It becomes the granola county.
That's right. Exactly. Exactly.
Okay. Let me take you back, before we get too far away from it, to the evidence about the climate. And you basically argue that you've got three indices that you kind of look at that say to you, this is going much worse than the models suggest, and sea level, ice cover, and ocean algae. Can you talk a little about that?
Yes, the IPCC, as you know, is made up of well over 1,000 of what are alleged to be the world's best climate scientists. but they can't get it right. They can't get it even halfway right. Look at that graph. That, you see, I'm rather stuck on sea level because it's such a good thermometer. The sea is contiguous around the whole world, so if it warms, it expands, and the only other source of it increasing in height, sea level, is the melting of ice going into it. Now both of those are measures of heat received by the Earth from the sun. So what's happening? It's going up linearly, as you can see on that graph. What does the IPCC predict? It would go up. That's that green range of values. I'm glad to say that our Hadley Centre in Britain is well on the top, nearest to the truth, but it's still nearly about 70% wrong, and on average they're about 100% wrong.
And so the meaning of that is that the climate
is more complex than they understand.
Yeah, and it's heating faster.
Yeah,
than they have.
That's right.
Yeah,
and the surface and atmosphere, which is what people talk about when they say the global mean temperature is such and such. The heat content of that is only 1/800th that of the ocean. So the ocean is the great flywheel, the dominator of the whole scene. And it's what the ocean that's doing that matters. Not, I mean, this cold spell now, the skeptics are all saying, where's the global warming? There isn't any. Look at it, the whole world's cold. It isn't. It's just the land masses which store almost no heat at all. So it's the ocean that really counts. That's one of my feelings about it. What were the other two questions?
Well, you mentioned ice cover. Well, and actually they're all three. They're all three: ocean sea level rise, ice cover shrinkage, and the decline of ocean algae.
Yeah, they are. They're all connected. Now, the ocean algae I haven't explained. The very interesting thing about the ocean, is that just purely physically, when the water temperature of the ocean on average gets between 12 and 14 Celsius, depending on wind and other surface conditions, it stratifies. And you get a warm layer on top floating above the cooler water below. Now that warm layer soon becomes denuded of all nutrients because algae living in it use them up, their dead bodies drop through, and so it just dries out and becomes a desert. And in the tropics now, in the great subtropical gyres of the ocean, it's the most complete desert on Earth, and by far the largest desert. There is no life virtually at all. There's more life in Antarctica than there is in the ocean gyres, and that's why the water is clear blue, and you can see right down to great depths without anything. There's no life in it at all. And that is getting bigger and bigger as the ocean warms, because more and more of the top surface is getting stratified. And that is a huge driver, because the algae pump back CO2. And they also produce clouds, which is one of the things that came out of Gaia research.
So there's another one of those positive feedback loops.
Yes,
right?
yes, two of them if you bring the clouds in.
Yeah.
So that and the ice melting, that's three. You can begin to see how they all add up.
Yes. And the graph you've just shown me, actually, another quote from The Vanishing Face of Gaia: if we are failing to predict what has already happened, how can we have confidence in predictions for 40 or 90 years from now?
Exactly. Yeah. I think, well, you've seen all the business about the leaks from the climate centres in the newspapers. Well, I was a bit naive. I knew many of the people at the Hadley Centre, and quite a few of them are friends of mine, and they're pretty good and honourable scientists. I can't imagine them fudging anything. But I'd forgotten the extent to which the rest of the science community is not very good. I think it's a consequence of well-intentioned liberal politicians who felt that it was unfair that only the rich could afford to be scientists as young people, and that it should be available to everybody. Well, that's fair enough. I certainly was exceedingly poor when young and became a scientist by doing it the hard way, starting out at evening college and working to as most Americans, I think, do when they go to college. It wasn't so in Britain in those days. You were either rich and you went to university or you didn't. It was fairly simple.
It was as stratified as the
That's
ocean.
right. But well-meaning politicians said this isn't fair. But they didn't look at the other side of it. It meant that increasing numbers of dumbos became qualified as scientists, and they didn't have the same kind of esprit de corps or moral standard that the older ones had. The older ones looked on science as a vocation. Money wasn't important. It was you did it as a life's work, like an artist does. The new ones look on it as a career, and they think first of their salaries, their tenure, and their pension plans, and only secondly of their science. Now, in such an environment, cheating and fudging becomes endemic. I think that's the problem. And I think back to the CFC ozone affair, which I was deeply involved with. In fact, I first measured the CFCs in the environment. And that was crooked almost beyond belief. It really was. The National Bureau of Standards did a study of all of the labs that were measuring CFCs in the atmosphere, including mine. I think there were 17. And nearly all of the labs were claiming accuracies of 5% or better. In practice, the scatter was 400%.
Really? Yeah.
And I know, because looking back, this is hindsight, I know that I was the only person in the world that could measure the CFCs accurately. Everyone else was using what they called standards. That was, they bought a standard dilution of CFCs from somewhere. Now, when you think about it, making a standard at parts per trillion, there's almost homeopathic concentration. It's an incredibly difficult job, and it couldn't be done. In fact, at that time, it was impossible. So they had bum standards. No wonder they'd scattered all over the place. I was using a totally different method. I used a detector which I'd invented that was absolute. In other words, the signal it gave was a direct measure of the amount of material it was detecting. And that was what I based all my measurements on. Yeah. Yes. Yeah. Yeah. And looking back to the first measurements I made in 1952, if you look at the curves of the amount in the atmosphere from good, accurate measurements and extrapolate them backwards, they go back to my measurements there. Right. So,
that's a spectacular story of what would seem to be success in spotting a problem and ameliorating it. The whole area of the ozones and the CFCs.
Yes, it was. And you see, this is the wonderful thing about science. In spite of a lot of fudging and crookery and things, who is the final arbiter? It isn't human, it's nature. What is happening to the world? That's the final arbiter. And what solved the ozone problem? It wasn't any clever model. The models got it wrong continuously. What was right was two observers in Antarctica looking up at the sky and suddenly seeing an ozone hole. That's what caused the Montreal Protocol to come to fruition, not the clever modelling.
This brings us back to another Lovelockian point, I think. Well, you've made the point quite vigorously that you and others have a kind of an addiction to going out and actually looking at what's there, and that's become also quite unusual.
I know, and governments will not put money into it. It's quite incredible. I think the last weather ship in the world is owned by Norway, and their government are trying to decide whether it's worth funding it or not.
Really?
Yeah. I was president of our Marine Biology Association in Britain. A strange position, but I never know why I was invited to become it. I can only think they couldn't find anyone else, but who would take the job, because it was at a bad time. And it was at a time when the government science, what we call research council, because the civil servants decide how much money should be spent on research, were in a mad mood of spending everything on models and nothing on measurements. It made more sense to the civil servants. And moreover, it meant the scientists all worked in a building in the main city, and they had direct control over them. Whereas if they went out wandering around the world, nobody really knew what they were up to.
Yeah,
You can see why the civil servants didn't like the idea of observation.
But the outcome is that graph, isn't it?
Yes,
the outcome of that graph is that
exactly.
you get a whole
That's
series
right.
of projections, and
Yes.
when you actually go and measure in the real world,
That's right.
that's not the way it's going.
And it was even worse with the CFC ozone affair. And you would have thought they'd have got the lesson from that, but they didn't. I think it's human nature again. We're a very tribal or hierarchical animal, however much we trend to be different. And every organisation of any kind goes tribal and has to have its leaders and hierarchy and all the rest of it. And they're always rival to each other. It's our natures.
I guess, as you speak, I think about an area that I've followed quite closely because of where I live and what my other interests are in, and that's the codfish collapse. And you know, there you had very good scientists in the government of Canada telling the truth, and the government of Canada actually falsifying the figures and, you know, suppressing the information to the point that they actually drove. Oh God, yes. And there was a wonderful scientist named Ransom Myers, R.A.M. Myers, who died tragically young, and you know, had been picked out by people like Time magazine as one of the 100 people who would really influence the future. And he was working for the government, ultimately quit, went to work at Dalhousie, and he was only one of many. But they would say things like, you know, you cannot issue licenses to fish northern cod at the rate that you're offering.
That's right.
In fact, you should put a moratorium on them. And they would say that's absolutely unthinkable. That would put, you know, 40,000 people out of work. So and the scientists would respond, you'll put them out of work permanently if you don't conserve the resource, right? And they are out of work permanently. I mean, it happened in the 1990s.
Exactly, but the politician was thinking of the next election, not of the distant future, and they still are.
Yeah, yeah. And I think that's one of the things we're facing with all of this, you know.
Well, the other thing that I haven't mentioned, and didn't even mention in the Ages of Gaia, the other book, Vanishing Phase, is the time scale. And this is the thing which I think we may have got more wrong than anything. The Earth system, when you think of that great flywheel of the ocean, it doesn't move very fast. And it can move fast, but it doesn't mean to say it will. And just making predictions based on models that the Earth is going to warm up at such and such a rate is wild. It's totally unjustified. There's no in fact, the current weather spell is an example of how daft it is. Mm-hmm. The surface temperatures can move all over the place without really...
Yeah, and we know if we watch the television news that the forecasting, you know, declines, the accuracy declines precipitously as you get 2 days out, 3 days out, 4 days out. That's days. That's not
days. You know, so what about 50 years?
Yeah.
And then to have whole massive policies based on that.
Yeah.
I mean, this is madness. And it's way beyond the election date, too.
Yes. Now, what would happen if we did have a flip of the kind you described, and if we had a sudden flip to 5 degrees warmer?
3 degrees in 20 years is about the maximum rate it's been observed to go up in the past. Well, that would be pretty bad. It would be pretty awful.
The normal, you know, the non-scientific mind says, well, 3 degrees, I can put the thermostat down a little, or, you know, I mean, it doesn't sound like a lot, but it is a lot. And I'd like, if you could talk a little bit about how that would appear in concrete terms in our lives.
Well, when you talk about the 3 degree global rise in temperature, you're talking about an average that will include anything up to 30 degrees rise in places as part of that average. And woe betide you if you happen to live where the 30-degree rise, you're sure as places won't be able to fix it by adjusting the thermostat. And that this is the point. And the land surfaces where people live are far more vulnerable to huge shifts in temperature, as we're seeing at this very moment, than are the oceans, which are 70% of the Earth's surface, and with a huge heat content for capacity for storing heat, so they only move a tiny amount in temperature. And if the oceans all go up 3 degrees, God help us.
Then you're looking at huge coastal inundations.
Huge
coastal inundations.
No, I'm not. I think sea level rise is quite low. You see that rate that's observed. If you extrapolate it to the end of the century, what is it? It's 3 millimetres a year. That's 3 centimetres in 10 years, or about a foot in a century, 30 centimetres. It's not much at all.
Okay.
That's not inundation.
So that's not one of the main concerns.
Well, it isn't, but that is not the only source of sea level rise. You see, if large chunks of Greenland start melting so fast they come sliding off into the ocean, or the Antarctic glaciers, any of those kind of events could cause sudden jumps in sea level. I don't know how big they would be, but that would alter the picture. So that 1 foot may become anything up to a metre or even more, which would be troublesome, but it's a long time for it to happen. It's not that matters. What matters with the ocean are what they call storm surges. Hurricane Katrina was a classic example of one of those. When you get a big storm or hurricane comes in, the low pressure in the middle lifts the seawater up, and it can rise up as much as 10 or 20 metres. And when that 10 or 20 metres comes in on shore, it is a gigantic inundation. And it does an immense amount of damage. I mean, a far smaller one than that, coming in towards down the North Sea in Europe, would take out London, Rotterdam, a whole pile of cities right the way around the North Sea basin. Completely.
We even saw that in the 1953 episode. In the
That's right. That nearly did London. It just missed it.
Yeah. And that was at a lower stage of sea level.
Much lower. And a repeat of 53 now would be very worrying, despite the Thames barrier. So the thing to worry about the storm surges, and messing about with the climate is liable to make it stormier, is another way of looking at it.
Yes, and those storms, you're right, they don't have to be all that high to be very, very damaging in a seaside city. Right?
Yes.
You commented that the first truly great environmental disasters, and maybe the same question another way around, but the first truly great environmental disasters will usurp the political agenda and displace many false ideas, hampering change. What would qualify as a truly great environmental disaster?
Well, the flooding of one of the major cities.
Okay, so something,
I mean, if London or New York was taken out by a storm surge of some kind. See, they made enough fuss about New Orleans. But New Orleans, well, look at it another way. Something very interesting happened that is not mentioned at all in the climate talk. I don't know why. But you might ask the question, why was it that Hurricane Katrina wiped out New Orleans, virtually? Now, Hurricane Ike, that came 2 years later, could have wiped out Houston and the whole of the Gulf Coast petrochemical area. That would have had catastrophic effects on the economy, not just in America, but globally. But it didn't. It fizzled. It came into the Caribbean as a full-blown Hurricane Force 5 from the Caribbean, into the Gulf, rather. But the Gulf water in when would it be, 2008 presumably, or I've forgotten which year it was something like 8 degrees Celsius cooler than it had been the previous year. Why? The Gulf Stream stopping. Why is the Gulf Stream stopping? Because the theory, and this is only a theory that a few climatologists I know have put forward, is that the melting ice, melting sea ice, is releasing enough fresh water floating down in the Arctic Ocean and the North Atlantic to stop the downwelling, which warm salt water that drives the ocean conveyor belt that keeps the Gulf Stream going.
And that's terrifying.
Well, in Europe, it looks very much as if the Gulf Stream has almost stopped.
Is that right?
Yeah, we're getting appallingly cold, wet summers. And look at this winter. It's not Ice Age. You see, they over-dramatize these things. the amount of heat carried by the warm water across the Atlantic to Europe is only 25% of the total. Most of the heat is carried by the westerly winds. And we can do without the Gulf Stream, but it's not very pleasant without it. It's turning down the heat too much. And if you doubt that statement, look at Seattle and Vancouver. There's no Gulf Stream in the Pacific. There is a current comes across, but it comes across much lower down than that region. And they're kept warm by the westerlies that flow across the Pacific.
And of course, on the East Coast, we're kept cold by the westerlies that flow
by
across
the
landmass.
opposite, yes,
Yeah,
and by the cold current coming down from Labrador.
From Labrador, yeah, absolutely.
So things are small changes can make enormous effects.
Well, absolutely, yeah. One of the elephants in the room. Sorry, and one of the elephants in the room in this whole discussion of our impact on the climate and Gaia generally is this huge population that we have. And you mentioned this a number of times, but it seems to me that is it possible to really address these problems without a huge die-off in the human population, which Gaia may be engineering at the moment? But
I don't think so. Yeah. I mean, in theory, if you had a wonderfully liberal world with all of the objectives of the United Nations fulfilled completely, everything, humanist and Christian and good, maybe we could solve it. But we don't. We're a tribal animal. We're going to go on fighting because that's our evolutionary history. I once asked a very senior biologist, John Maynard Smith, who was an enormous opponent of Gaia, so much so he referred to it as an evil religion, not a science at all. And anyway, he came right round in the end. It won him right round. He never went public, unfortunately, before he died. But I asked him, I said, what do you suppose would happen if the genetic engineers found a tribal gene and then got rid of it for people? Would it make us any better or worse? And he pondered quite a bit, because it's quite a question. And he said, oh no, he said, don't even think about it. He said, there is no tribal gene. It'll be a whole system of distributed genes, and there will be no way of taking them all out without affecting so many other things as well. It probably wouldn't be viable. And that was a really good geneticist kind of response, and I think it's probably correct. So we're doomed, as we are, to be tribal animals. It'll take a lot more evolution before we solve that one and become social animals like bees and ants and things. And even then, we'll probably still be tribal in a different sort of way.
But that's why, for you, it's important for human beings to survive this crisis, which may be inevitable.
Well, I think it's important for Gaia. You see, I look on human beings as an important and evolutionary step in the history of the planet, as with the photosynthesizers. Like the photosynthesizers, we cause a frightful mess and mayhem all round when we first appear. So did they. But gradually things adapt, both us and them, and you finish up with photosynthesizers as giant redwood trees and admired by everybody and producing the oxygen you can drive your cars with. I mean, nothing but a benefit. And our intelligence, if it could be integrated as part of the whole planetary system, just as oxygen's been integrated into part of the planetary system, would give our planet, make it the first intelligent planet in the galaxy, perhaps. And that would be what a wonderful future for humans.
Wouldn't be humans, though, would they?
Well, yeah.
It would be related to humans, as I suppose we're related to the sort of proto-human species.
That's right. That's right. Well, the cyanobacteria that started the oxygen are not redwood trees.
Well, I was thinking more like Neanderthal. But,
well, quite. Yeah, but no, I mean, but that's the way life goes, isn't it? And there's no bitching about it. I mean, be grateful that you're in such a wonderful royal family, so to speak.
Even if it's doomed. But one of the things I guess that strikes me very much when I read you is that I think most of us find ourselves traveling down certain paths of logic and realizing at a certain point that they're leading in a direction that we really don't want to contemplate. And you seem to have a capacity to proceed unflinchingly based on the observation and the implications that you see in it. It's a remarkable quality, I think.
I don't think it is. I think if you go back to the Enlightenment, they mostly had it then. And if you read their stuff, it's very clear they had it. It's that science has become so constrained by society and by politics that it's almost impossible as a scientist to think like that. I mean, what made me go off on my own at age 40, amongst other things, were silly people who would say to me, "Oh, you can't do biology, you're a chemist," as if I was of the wrong tribe. Not that I had a brain. And this is so common. If you are free, then you can just think, and I've been free for a long time now, 50 or more years, it gives you a different perspective on the whole world.
You see, I mean, you seem also to have been able to conquer ego to a very large extent in that same way. And,
well, the more you know, the more you don't know. And the more you branch out and get familiar with a wide number of branches of science, just as those Enlightenment folk that I so admire did, the more you realize how much you don't know.
I began a speech the other day by saying, as I get older and learn more and more, I discover that I know less and less. And
exactly.
I find this somewhat
That's right. You're more of a generalist and less of a specialist.
Yeah,
yes.
Yeah. I seem to have known more when I started than I do now, which is a bit disturbing.
One was more certain.
Yes.
You see, one of the things you learn, or should learn as a scientist, you can't be certain about anything. But the politicians require you to be certain. Well, we can't pass this law unless you're certain that this is good.
Yeah. Which is a strong argument for, well, you must be among a very small number of people that have been able to sustain yourselves without an major institutional connection through most of your working life.
And had two major disciplines, earth and life sciences, not only attacking, but I endured a censorship just as great as Galileo did. It wasn't as threatening in the sense that it wasn't life-threatening or anything like that, but from about 1980 onwards, no paper I published would be accepted by any journal. It was not the editors, it was the peer reviewers. They were so sure that anything to do with Gaia, and therefore anything with my name on it, was not proper science, it was just New Age nonsense. And therefore they could safely reject it.
And has that changed?
Not much.
Really?
No,
really?
It's still pretty strong.
Because the Gaia theory and you personally have this huge respect in the rest of the world. I mean, we have.
Well, I can show you some recent correspondence from the Geological Society of London, who are thinking of holding a meeting this year, sometime later in the year, on earth science. And they specifically state, the people drawing up the meeting, they mustn't have the word Gaia associated with it at all. It's not proper science. It's the kind of...
Well, yes, but...
And that's now.
Yeah.
But the same society awarded me their Wollaston Medal, which is their highest honour, about 5 years ago. It's just that a small group got together and got me that award, but the great bulk are still back in the Stone Age.
Are they bothered by the ideas or by the name?
Mm-hmm.
Are they bothered by
it's the
name
association. No, it's not the name, because when Bill Golding first suggested it, way back in the 60s actually, and I went around using it, the climatologists and atmospheric chemists to whom I first talked about it were very happy with it, and seemed to think it was quite a good name, and no objections at all. It was only when those very vociferous biologists And they were vociferous. And I mean, I look on Richard Dawkins as a kind of Rottweiler who was employed by the establishment to tear this thing apart, and he did, and did it very well in beautiful English. And it just never recovered from that as a concept.
But did it not recover somewhat under the name Earth Systems Science?
Oh yes, but that was a cop-out, you see. Earth Systems Science was founded by the students of James Walker, who was a violent opponent of Gaia. He was utterly determined as an old Earth scientist that Gaia was nonsense and that everything could be explained by simple geochemistry and geophysics. That if there was any regulation, the biota were not involved, they were mere passengers. And they published a paper on on what they call chemical rock weathering, somewhere in the early 80s, about 1982. And what they said was the temperature of the Earth is regulated by the removal of carbon dioxide from the air, by its reaction with calcium silicate containing rocks when rain containing carbon dioxide falls on them. And the feedback was the warmer the Earth gets, the more rain falls, and therefore the more CO2 is taken from the air, and so it's a negative feedback and it self-stabilizes. And that theory is still believed to today in the United States, widely. And quote, and if anybody talks about climate regulation, there was a paper last summer by Ken Caldeira and somebody else taking the ice core data to demonstrate that the temperature of the Earth really was regulated, and it was by regulating the amount of CO2 that demonstrated it mathematically. But they quoted the Walker mechanism, not anything Gaian. Because that's the paradigm, goes that way. Yet, within a year of the publication of that Walker paper, Andrew Watson, my student then, and I had a paper in planetary and space science. We couldn't get it in mainstream journals, pointing out that on the rocks, there always are organisms living. There's lichens on the rocks everywhere. And in the soil, if you analyze the gases of the soil, you find there's 30 times as much carbon dioxide in the soil as there is in the atmosphere, because microbes are continuously consuming plant detritus that's fallen in there, and the CO2 doesn't escape immediately, it builds up in the soil. So the rate of weathering of soil particles coming off the mountains in the soil is at least 30 times greater. So the biota is deeply involved in the process of chemical rock weathering. But the Earth system scientists won't have that. It's all chemical.
It's curious, isn't it? It's almost theological.
It is theological. Yeah. It's a purely religious response. And that's why I said I feel like Galileo. And their response was just like the church's establishment then. You cannot challenge any of the dearly held beliefs.
Tell me about sustainable retreat. How would one accomplish that?
You do change subjects fast. Well,
you've given me a great deal to think about. I guess that's it.
Well, as a Canadian, you should worry, because one of the obvious ways of sustainably retreating in the United States is to move north. And they'll buy the whole place up. They'll not go to war. For a moment, I don't suggest that. Indeed, I gave a lecture at Stanford, I think it's nearly 4 years ago now, and it was really quite funny. It was the first lecture I've ever given on this sort of topic, including Gaia, where I got a standing ovation. And afterwards, the students came up to me and they said, "Tell me, Professor, where would you go now that things are... Do you think it would be a good idea to move to Canada?" And I said, well, I was taken aback by it. You mean that's going to be your... Yes, why not? I mean, we're young, we could move up there. If that's what the world, that's going to be a sustainable place to live, then we'll go there. And it wasn't long before their professors came up and said, well, yeah, we heard what you said, but we're a bit old for moving up to the north in Canada. Did you think Victoria Island would hold out for us? That was a response at Stanford.
Isn't that astounding?
But it makes you think, and that's in a way what I mean by sustainable development. It's survival, really, is the element of it.
It's tribal and individual, isn't it?
Yeah, so humans have got to survive. And when you go back to the last great heating incident, which occurred 55 million years ago, when about the same amount of CO2 went into the atmosphere as we will have added in about 20 years. And that's 1 trillion tons, I think it is, of carbon. And there was no great extinction. But the planet became intolerable by our standards. It was largely desert. And life was driven to the Arctic basin. The Arctic Ocean had a surface temperature of 73 Fahrenheit. And there were crocodiles living up there. You can find their remains. It was a tropical Arctic Ocean, and the rest of it, as I say, was hot desert. But there was no great extinction because life had time to move there and to move back again and re-inhabit the Earth. So that's an example of biological sustainable retreat.
Right. And that would, I suppose, be, but of course, we're not, we're not talking about giving the system much time, are we? We're talking about a change here that would occur much faster than that one.
Well, we don't know. This is the thing. I think I was misled in my first book, The Revenge of Gaia, into thinking the IPCC and others were more or less right. There was this drive. But as you saw in my second book, I'm beginning to question that. I think that they've been basing their arguments mainly on too simplified geophysics. It doesn't include enough of the ocean, it doesn't include enough of the biota, all sorts of things they've left out, and you can't leave them out. And that's the evidence I had that suggested that you can't leave them out.
So, which leaves you thinking that it may be a more gradual flip than you had at one point.
It could be, but I might be wrong on that. Yeah. But if you look in that thing, I think there's a second, no, this one, there's a second diagram here. This is only a rough draft. That's how the actual warm-up from the last glaciation. And you can see over we're talking about thousands of years. It first of all goes in a series of lumps and then it goes right up. Then right the way down to lower than before it takes off. Now, if that kind of thing repeats, we're talking about something that might be as long as 1,000 years before.
In which case there would be a little more time for adaptation.
But it might be next week.
Yeah.
Who knows?
Yes, I can see the frustration of being in your position and having people say, well, tell me what's going to happen. And
I don't know, it's the true answer.
Yeah. But you are quite concerned, and you basically do think we should be putting some effort into figuring out how to survive as civilized people, not as warring tribes, right? Yes,
well, if you think about it, when the Roman Empire collapsed, I often think of myself as a bit like a suburban Roman living at 450 AD, and the whole thing is falling apart. And my wife says, Jim, I don't know how the places we're going to keep warm this winter. There's nobody to repair the Hippocaust. Oh, never mind. Go out and get a barbarian. You'll find one of those who'll have the skills to do it. But it is a world a bit like that in many ways. And it certainly is true in Britain. I mean, plumbers no longer exist, but there are plenty of people coming in from Africa, from Europe and elsewhere that are quite competent plumbers, and they'll fix it. But they're moving in, and the population's steadily rising and rising and rising. And we couldn't sustain ourselves in World War II, even with the little food coming in on ships. If there's none coming in because the world has changed, well, what are those 100 millions they reckon there'll be eventually there? What are they going to be fed on? Because you can't grow it.
And so, what action should you take then?
I'm damned if I know.
So much of this leads to a big die-off, no matter how you come at it.
I think face up to the fact this is one thing, that there probably will be a gigantic die-off. And if it goes through, as the IPCC predict, and we rise about anything up to between 3 and 6 degrees by the end of the century, then I don't think there'll be more than 1 billion left on the planet. But that's guesswork. I can't really quantify that.
Which leads me to remember your project of synthesizing food from directly from CO2, nitrogen, and water and trace metals. And you remarked at one point that we don't have the time to do it now, but surely it's one of the things we should be pursuing at flying speed, isn't it?
Well, if you want to do it, to start, you've got to start rebuilding nuclear power stations like mad. Get over all this absurd fear of nuclear energy and the masses of legislation that the Greens have gradually introduced into governments around the world, so that it takes something like 15 years to build a nuclear power station. 10 of those 15 are spent in the courtrooms. 5 you can build in peacetime. If there was a real wartime type of effort, you could build them in 2 to 3 years. And the Koreans reckon they can do it in 2.5 years anyway. It's just that, but you've got to do that first and have the power, because you can't go on burning coal to do it, and you're not going to bury the CO2. That's a joke, a bad joke, I think. And you're not going to do it with wind power or something like that. So you have to face up to the fact there's only 2 possible sources of large-scale electricity. One is nuclear, and the other is solar thermal. And get cracking and do it. I mean, governments in Europe, for example, our government is spending 100 billion on wind turbines around Britain. They know damn well they'll never produce the electricity. And when they do, it's intermittent and unreliable. They're doing it because it's European solidarity. I suspect our politicians have been promised all sorts of good jobs in the European community if they support this thing, because it provides jobs for the Germans and the Danes and others who are building the things. Not because it's any intrinsic good.
What are the prospects for fusion? Because that would be that would be, in a sense, almost the best possible solution.
Well, I've talked to the director of what was our effort at Cullum, and I think he's become put in charge of the new system somewhere down in France. And he's very enthusiastic about it, thinks that if they had the funding was from government, it really took its finger out, they could probably get fusion going as a source of power in about 30 years. But it's a long time ahead. And meanwhile, there's nothing wrong with fission. It works. And if you do like the French do, and reprocess the plutonium produced in their reactors and feed it back into the next lot of fuel that's going, you can gradually get, I think they're getting 30% of the energy of the uranium back. And in principle, you could get more than that as you gradually engineering improvements come along. Now that's pretty good going. They're producing the cheapest electricity in Europe, and they're run entirely on it. So it can be done, it's proven. It's pure panic that stops people using it, and the Hollywood and media with crazy stories about blow-ups and absolute lies about Chernobyl.
Mm-hmm. Yes, your point about that one is very interesting. The death toll from that is tiny.
I know, it's almost negligible. It's just a nasty industrial accident. But you can't blame the Russians who've gone along with this. The people in Belarus, where they got the most of the radiation from the thing, are very poor people. It's one of the regions of Russia that didn't do too well. And when lots of crazy Westerners come along, they say, oh, you poor people, bring us your disabled, your whatnot. They did, in droves. This is what the radiation did.
But your point about it is that even if you take the death tolls to be quite serious, what it really means is a small reduction in lifespan for the people affected.
Yes.
So it doesn't mean that there were all these thousands of people dying right now. It means that my life might have been 3 weeks shorter.
Exactly. And who knows anything about that?
Yeah.
It's not commonly known. We had a similar fire to Chernobyl in Britain in 1957. And it so happened also that I was able to observe it 250 miles away from the actual reactor that caught fire. I was working in London on medical research and using I-131 as a tracer. And suddenly I found we couldn't do any measurements. The background in the lab had gone right up through the roof. And I thought I'd done something silly, like spilt my iodine on the floor or something and not noticed it. And until somebody knocked on the door and said we're experiencing the same thing. And there was a big inquest. We all thought we'd made a mistake because in those days governments kept that kind of thing completely dark. D-notice was sent to the newspapers, they mustn't report it. And because the reactor was being used to make plutonium for export to America, I think, mainly. And part of our balance of trade.
And it was, and in the end it had no, well, you're 90. You know,
well, I'm still here. The health service in Britain may have its drawbacks, but in those times it was keeping wonderfully good records. And the whole of Britain practically was under the cloud of this darn stuff. And there is absolutely no record whatever of any increase in cancer rates or anything else over that period, over the long, long period since.
And you make the same point about even the nuclear testing in the 1950s that scared it.
Well, that was huge in the 1960s, yes. I mean, you can still pick up the C14 in people's teeth and use them for aging people from that test.
But it doesn't seem to have had any major
effect on the world, no.
No, in terms of public health or anything like that.
Well, I wouldn't expect it to. It's again one of these great myths that arise. It's rather like the myth that occurred during the ozone CFC controversy, that if the ozone layer was damaged, all life on Earth would be destroyed. Plenty of newspaper headlines like that. It's just nonsense. If you got rid of the ozone altogether, it probably wouldn't make much difference to life on Earth. White-skinned humans like us would have to wear skin block and a hat when we went out, and not sunbathe. But apart from that, it wouldn't be.
Well, that's one of the most bracing things about your work. Is it seems to me that underlying it is a deep faith that the Earth is basically a very resilient planet.
Yes.
We may not be as resilient, well, we are not as resilient as the planet is, but we're
pretty
much more
tough.
resilient than we think we are.
Yeah.
And there's a lack of fear in your way of looking at these things, which I think is very bracing.
Well, thank you. Well, I think it's justified, really. I mean, dash it all, there's been life, wet, messy stuff, running under very limited range of conditions. Everything has to be just right, the right salinity, the right pH, the right everything inside our bodies. And that light stuff's been around for 3.5 billion years. That's about a quarter the age of the universe. Much longer than many stars. I mean, it's incredible. That's a pretty stable system, isn't it?
It is.
By anybody's.
It is. I'm going to make 2 more abrupt jumps on you, and then perhaps bring this to an end. The first is that you refer to the urban. Number one, you refer to yourself as, you think of yourself as a green, and you have a great definition of a green as being somebody who senses that there's something very wrong about that the Earth has been deteriorating and wants to do something about it. So I think you're right to put your finger on the sort of moral center of that as being people's desire to be of service, I guess. But you also refer to the urban green ideology as being perhaps the most deadly ideology of them all.
That's right.
Can you explain first what the ideology is, and second why it's so deadly?
The ideology is just pure, simple humanism. They think of it purely in human and personal terms. Is there a carcinogen in the atmosphere that will shorten my lifespan? Is there a kind of response? They don't really think about the world at all. Rachel Carson's message when she wrote her famous book was about the destruction of wildlife, birds, Silent Spring. It was rapidly translated by the press and the media into there's carcinogens around in every city you're breathing, and they're in the food residues and things. And that it became a personal human thing that the government ought to do something about. In other words, it entered the political arena. And that's what I dislike. It should be a moral issue, not a political one.
And a moral issue that relates to all species and not
Yes,
just to this one.
Exactly.
Yeah. And, okay, and perhaps the most deadly because it focuses our attention on us and removes it from the rest of the world.
Yes.
Yeah. Okay. The other big jump is, tell me about your proposed flight on Virgin Galactic. Is that going to happen?
I hope so.
What's the state of play with respect to that project?
Well, I went to Los Angeles in December, on December the 7th, to see the run-out, the display of Spaceship Two, in which I hope to go. And as far as I know, it's complete and ready to go, but it has to get FAA approval, and there'll be test flights this year. When they're approved, I hope I'm on it. Going up and see Gaia for myself. I think it was such a wonderful offer from Sir Richard Branson. He's a nice man. Well, I think so. Having met him.
Spectacular offer.
Yes, really I'll say.
Yeah.
Well, he's been a Gaia fan, you see, for a long time, and a closet one.
The Green Interview is co-produced and directed by Chris Beckett, with the generous cooperation of Mount St. Vincent University in Halifax, Nova Scotia. For The Green Interview, I'm Silver Donald Cameron. See you next time.